addition to what we discussed about the thermodynamics of electrochemical cells, we can also evaluate delta H and delta S from EMF data. So recall your Gibbs-Helmholtz equation, which is delta G minus delta H equals temperature times the differential of delta G with respect to delta T at constant pressure. And we know that the relationship between change in Gibbs free energy and your electromotive force is given by this equation. And if we differentiate this with respect to temperature, we have the differential of delta G with respect to temperature, constant pressure, equals negative N Faraday's constant times the differential of your electromotive force with respect to temperature at constant pressure. So if we substitute this one and this one to our first equation, the Gibbs-Helmholtz equation, we get negative NFE minus delta H equals negative NFT times the differential of EMF with respect to temperature at constant pressure. And if we isolate delta H and cancelling out all the negative signs, we have delta H equals NF times the quantity temperature times the partial differential of your electromotive force with respect to temperature at constant pressure minus the electromotive force. So this equation allows us to evaluate the change in enthalpy if we have the measured electromotive force or EMF and the temperature coefficient of EMF. So this one is called the temperature coefficient. So in this equation, your delta H must be in joules, given that your EMF is in volts and your Faraday's constant is given in coulombs. It's able to get delta S from your EMF data. So if we substitute this equation in our Gibbs-Helmholtz equation, we have delta G minus delta H equals negative NFT times the temperature coefficient of EMF. And we have the famous Agatha's equation, so since the left sides are the same, we can equate the right sides of the two equations. So we have negative T delta S equals negative NFT times the temperature coefficient of EMF and then if we divide the whole equation by negative T, we get delta S equals NF times the temperature coefficient.